Okay, so we're going to have a look at the next part, which links to 6e. So we talked about tangents last time, but now we're going to talk about perpendicular bisectors. And perpendicular bisectors go along with chords as well. So what we have in this question, we have a chord from P to Q, okay, which makes the line segment PQ. So, we're just sort of describing what's happening over here in the diagram. If you find the middle of this, and helpfully here this has been called M, one reason why you might want to do this is because this is necessary if you want to find the perpendicular bisector. As we talked about earlier in the chapter, we find the gradient of PQ. If it's perpendicular, we can use the negative reciprocal, and we can also use this coordinate M, and that will give us this line here. It's called L. And what do you notice about this line L? The center of the circle is on this line, and this will always be true. This is a circle theorem, okay? So, if we work through this question, find an equation for L. Well, same as before, we're going to do the perpendicular bisector. So the middle, by inspection, you've got -8 and 2. So -3. And what's between -2 and -6? It's -4. So this will be your point M. The gradient, you can define the gradient by doing the difference in y over difference in x. And once you've found, let's call it the gradient for a chord, you will be able to use that to find the gradient for the perpendicular bisector. So the difference in y is -4, okay? And the difference in x is 10. So the negative reciprocal gives you 10 over 4. And if we quickly look, the idea that this line has a positive gradient, that seems to match. A steep positive, 10 over 4, sounds good. So we put our coordinate with our gradient, and we will get the answer to part A. So there's the chord, and here is the perpendicular bisector. Notice they've simplified, but you don't need to do this. And M has been used. This one here has been used in the final equation form. So nothing new there. Given that the y coordinate of C, so the center has a y coordinate of -9, show that x is 5. How do we do this? Well, what we can say is this line here should link x's and y's together. So if you put -9 into your y value there, if you sub in -9, it should return an x value. And that x value is -5, which we needed to show. Finally then, find an equation for the circle, where a circle has the part about the center, and we've just found that. We know that the center is -5, -9. The other component is the radius. So after we've put in -5 and what was the other one? 9. You can do some Pythagoras, and I suggest maybe you do some Pythagoras from C to Q, okay, to find this here, because this will be your R value. If we reveal, what did they do? They did P to C, but you could do C to Q, you'll get the same answer, you'll get the square root of 58. So we remember that we need to square it for the final form. Question on the left, we did in the last lesson, so you don't need to do this one here. Have a go at the bisector question on the right-hand side by pausing the video. Assuming you've done that, a quick sketch as well will help you out. So you find the gradient of A and B. The perpendicular gradient will be for the bisector. The midpoint for AB will also be the point that you use in the equation. Plug all of that in, you will come up with this equation. You could simplify, but without even simplifying, you put in the value that is known, that's -1. and it will return a y value. You now have your center. A bit of Pythagoras to finish will give you your radius as well. And you can pick up quite a lot of marks in your papers by just remembering these steps and how it links together. One thing I haven't done in the video that I would encourage you to do, though, is, again, a quick sketch every time, just so you can see if there are any obvious errors in your working, such as gradients, perhaps.